Hello students, how are you all? I hope you all are doing very well preparation for your upcoming exam, that is pre-board of your class 10th. In today's video, we are going to understand, or we are going to get the knowledge or idea about the topic, that is metal and non-metals. In the previous video, I have explained you about what are metals and on their properties, like physical and chemical properties. They are categorized into two. So we have learned the physical properties of metal also and chemical properties of non-metal also. What is the difference between physical property and the chemical property? A very simple example I'm going to give you, that we human beings, physical property means how your appearance look like is a physical property. Like if all are having two eyes, one nose, two ears, two hands, two legs to walk, so all are more or less looking alike, irrespective colors and features and everything, but main features all are having same. And chemical properties we can consider it as nature of every human being are different. No one is similar nature wise with each other. So in today's video, we are also going to learn about non-metals. In previous video, I have explained you chemical properties of metal, and in that we have learned the reaction with oxygen, with water, with acids and etc. So in today's video, we are going to understand about non-metals. Metals and non-metals, they both are different. What are non-metals? Non-metals are those elements which form the new element that are a negative ion, and how they are making it by getting or by gaining the electrons. They are gaining electron from the other substance. Examples are iodine, sulfur, oxygen and hydrogen. They are example of non-metal. All the non-metals exist in either solid form or in the gaseous form, but definitely excess, or we can say some exceptional cases are there. So bromine is a non-metal which exists or which we get it in the form of liquid. It is exceptional. Coming on the physical properties of non-metal. Now physical properties of non-metal, definitely we are going to compare this property with metals. First property is malleability and ductility. Metals can be malleable or ductile. They can beaten up into sheet, or they can drawn into a wire, but non-metals cannot be beaten into sheets or cannot be drawn into the shape of wire. Second one, brittle. Non-metals are brittle. Examples are sulfur. Sulfur is a brittle substance or brittle element. Next one is the physical state. Physical state is that all the non-metals, the physical state of non-metals are vary from 1 to 1. One substance, that is diamond, it is allotrope of coal. It is the hardest substance, or it is the hardest element, or sorry, not element, it is hardest non-element. Now coming on next one, the luster. Luster is the shining property which we are getting on metal. An example is gold, silver. So they shine, and from their shining only we can recognize the metals. So they are also lustrous, but not all. Few are lustrous, like examples are diamond and graphite. They are also allotropes of carbon. They are having lustrous property, but remaining all are non-lustrous. Now coming to next one is in non-metal, iodine is also one of the example for the lustrous property. Next property is electrical or the thermal property, that electrical or thermal conductivity, means good conductor or bad conductor of heat and light. So we are going to compare this one. The conductivity of graphite, this is also an allotropes of carbon. This one is poor in conductivity of heat, or the thermal conductivity of this non-metal is very poor, but carbon is having very good conductor of heat as well as light. Melting point and boiling point, non-metals are having very low melting and boiling point, but again exceptional case, borax, silicon, carbon, they are having very high melting point and boiling points. Now coming on chemical properties. Chemical properties definitely are different from metals. First one, they always react with water or steam, or we can say with the dilute HCl, or that is hydrochloric acid, and they give hydrogen gas. How we are getting this? The electron accepting this, and because of that reason they are evolving hydrogen gas. Now one thing is that they cannot supply electron to, they cannot give the positive electron of hydrogen in presence of acid. So for that only they react with to reduce into hydrogen. Again I am going to repeat the same. It means non-metals do not react with water, steam or dilute hydrochloric acid to evolve hydrogen gas. Why? The reason is that they are electron acceptor. They accept electrons. Because of that reason they can't supply electron, they receive. अगर टेंडेंसी उनका लेने का है, उनकी प्रॉपर्टी है, they used to take, so how can they give? So non-metals are having property to accept that. So in that condition, when they are accepting, how can they transmit the electron? So that is the reason they are not able, they cannot supply electron, that is hydrogen and of the acid, to reduce and give the hydrogen gas. Most of the non-metals are acidic oxide and they dissolve in water. On heating, when we heat, non-metals gives us oxides, or in that condition they gives acids also. So now we are going to understand about the reaction. When on heating sulfur with sulfuric acid, and this sulfuric acid is concentrated sulfuric acid, heating we are getting, that is SO2, sulfur dioxide, and water. Here we are getting water. Now again sulfur one is reacting with concentrated nitric acid. On heating it is giving us sulfuric acid, that is H2SO4, NO2, that is again a form of oxide of nitrogen, and water. Next equation I am going to explain you about chlorine. When chlorine is reacting with sodium bromide, we are getting NaCl, that is sodium chloride and bromide, and this reaction is also known as displacement reaction. Why this one is known as displacement reaction? Because displacement reaction is having property, or it is having a tendency, whosoever is the weaker element, they are going to break down that only and they are going to make it separate. So here sodium bromide, here bromide is, we can say, is weaker. So in that condition sodium is going to react with Cl2 and it is going to make NaCl, and the main thing Br will be out of the reaction. So same happened here, and that is the reason we call it displacement reaction. Now, reaction between metal and non-metal. The reaction between metal and non-metal, they always form ionic bond. How they form ionic bond? Each element, they want to complete their outermost shell with either 2 or 8 electrons. Same way here also they try to form, or they try to make the complete valency shell, where in that condition 2 and 8 they want, and metal are having tendency to lose the electron. Metals are having tendency to lose the electron and form positive cations, or they are used to make positive cations, while non-metals are having tendency to gain electrons and form an ion. They are negative ions. When metal and non-metal both react with each other, they try to achieve the outermost shell. Both are reacting and they want to achieve the outermost shell, that is, it could be 2 or it could be 8. How? By transferring the electron. Now, how they are transferring the electron? When they are transferring the electron, the ionic bond is forming. This ionic bond they are making with the help of, this is also a chemical bond, because some chemicals are forming, and that is the reason they are completing the transfer of electron from one atom to another. They are able to transfer their electron from one atom to another atom. This one is known as ionic bond, or the compounds are known as ionic compound. Now we are going to learn more about next. Now we are going to understand about the reaction between metals and non-metals, that is ionic bond formation. Ionic bond in which they are either losing the ion or they are getting the ion to complete their electronic configuration and the outer octet sub. So first of all, I am going to explain you about Na, that is sodium. This one is metal, and when we are going to look at the figure, I am going to make figure for Na. You can observe that in the inner shell it is having 2 and in K shell, 8 in L shell, and in the outer shell, that is M shell, it is having 1 ion. Now coming on for second example I have taken, that is Cl. In Cl, in inner, that is K shell, it is having 2 ion electrons, we can see. In L shell it is having 8 electrons, 8, and in the outer shell, that is M shell, it is having 7 electrons. Now how they react, I am going to explain it. You must have observed that in the outer shell, that is in M shell, it is having only 1 electron, and chlorine, it is having outer shell 7 electron, and it is chlorine is non-metal. When metal is reacting with non-metal, what will happen? One thing is that who is able to gain or who is able to lose. Who is having more is really unable to donate 7 electron to the other one to neutralize or to balance the shell. But who is having the less number of electron is able to share the electron easily, or it can give the electron to the other one element. So same way here, when sodium is having 1 electron in the outer shell and chlorine is having 7 electron in the outer shell, to complete the octet in that condition, either it is one should go for 7, so chlorine is not going to give 7 to Na. It is really difficult task, but for Na it is easy to give this 1 to Cl. This 7 giving is not possible. So in that condition, Na is giving its 1 electron of outer shell to the chlorine, and that is the reason Na is reacting. Na is positive and Cl is negative. So they both are opposite charged particles, and due to force of attraction they can combine and they can form a new element, or new compound. That one is NaCl. The same example I can give you for magnesium also. Magnesium and chloride, when they are having, in magnesium they are having 2A2, means in outer octet they are having 2 electrons, and chlorine again it is having 7 electron. So 2 cannot gain 7 electron from chlorine, but 7 can take 2 electron from Mg. So in that condition it is easy to give this 2 electron to chlorine instead of giving 7 to magnesium. This way they are working together in ionic bond formation. Coming to the next one, the properties of ionic compound. First one is the physical nature. The ionic compounds are very hard in their structure, and they are found in crystalline solid form. Why? Because of force of attraction between molecules. The force of attraction between the positive charged ion and the negative charged ion, they are very hard. Second thing, they are hard, that is the reason they are brittle, and they are brittle when we are applying external force with excessive limit, then only it can break. It can break, but it cannot change the shape due to the same reason. Coming on the second, melting point and boiling point. Definitely they are having ionic bond, and to break ionic bond we need higher or highest melting point or boiling point to break the ionic bonding. So that is the reason they want high energy to break down the ionic bond, and the inter-ionic bonding is also very strong. That is the reason they need a very high level of energy to break down. Coming on, next one is solubility. They non-metals are easily soluble in water. That is the reason they are polar solvent, and they are insoluble in organic solvent. That is the reason they are non-polar solvent, and the examples are kerosene, benzene, ether, petrol, etc. Now water is polar solvent. That is the reason it is having tendency, or it is having a property to separate the opposite charged ion from their ionic compound. While next one is conduction of electricity. They are ionic or electrovalent compound. That is the reason they are good conductor of electricity, but they can pass on the electricity or heat only in molten or aqueous solution. The reason is that when it is in the form of solid, they cannot leave the bonding between them, but when they are in molten form or when they are in aqueous form, the bond or the force of attraction between the ions are loosened up, and that is the reason it is easy to make them separate due to that reason. And when they are away from each other, so electricity or heat can pass on very easily between the gapping or between the interspace of ions, and they can supply the heat or electricity properly. But in solid form, the ion bonding is very tight, or there is no inter-ionic space between them, and due to that reason it is difficult to pass on heat or thermal activity. But here in molten, the ions are loosening, and due to that reason, when they are having inter-ionic space little bigger, so through that gap heat or electricity can be passed on. So that is the reason in electrolysis we are using the molten or aqueous form of solution. Now we are coming with the next.